today we're going to turn it down a notch, and we're not going to light anything on fire. And we are going to take some time and just quickly go over some things that you should already know. This is probably something that you start every year with. So we're going to talk about identifying controls and variables, and we're going to talk a little bit about graphing. So today is a chill in your seat notes kind of day. So you're going to want to grab your packet. If you did not get the packet, print the packet, whatever, write me an email. Today would be extremely hard to do without the packet. So if you didn't get it, let me know, and we're going to see if we can arrange something for you. If not, and you just want to try to write this all down, go ahead. I guess you could read it all online. All the keys are underneath this lecture. The worksheets are underneath this lecture. But you're going to start with the paper that looks like on my screen. It says Notes on Identifying Controls and Variables. So the first thing we want to talk about is what is the control. And the control in any science experiment is going to be the norm. Okay, it's going to be the standard to which you will compare anything else. So it's the normal, it's not changed, it's not tested, it's your standard that you're going to have used to compare. So again, you should be writing along in your worksheet, or if you want to write this on a piece of paper, you're learning about the control. Then the dependent and the independent variable, sometimes they're hard to remember and keep them straight. So the dependent is the one that depends on the independent. So the dependent is going to be the one that's going to be measured. Okay, it's the one that you're going to measure, or you're going to observe, or the one that you're collecting information on. So the dependent variable is the one that is measured, or the one that is observed. And because we are going to talk about graphing a little bit later today, you need to know that the dependent variable, so that you can kind of see the way that it works going up and down, and you can see the changes like that. The dependent variable is going to be on the vertical or the y-axis. Okay. Awesome. The independent one is not the one that's going to change, okay? It's the one that you're actually going to be testing. So the independent variable is what you are testing, or you can think about it as what you pick, okay, in order to be tested. And that is always going to be on the x-axis or the horizontal axis. Okay. And as always, if I go too fast, because I can't see you guys, go ahead and pause if you need a chance to write these things down. Okay. All right. Then you'll see for the rest of the worksheet, there are some little snippets of some case studies, if you will. I wrote them a while ago, had a little fun writing them. But you will have a case study probably on the quiz this week and on the final test. So we'll give you some stuff you got to be able to pull out. So it says, Mrs. Bay thinks that drinking Monster energy drinks will increase the productivity of her students. She takes 2 classes of 30 students and assigns each the same task. In this case, they're supposed to copy the statement, "Chemistry rocks," into their notebook as many times as possible in 1 hour. Class A is given Monster drink while they work, and Class B is not given anything to drink. And after an hour, Mrs. Bay counts how many times the class copied down the statement, "Chemistry rocks." Group A copied the statement 1,587 times, and Group B copied the statement 2,113 times. So let's break this down really fast. So we said Group A is given Monster. So Group A has the Monster. And then Group B is not given anything to drink. So Group B is how you would regularly be in class. And I cannot write with this mouse. Oh my, we're going to have to figure something out about this. Okay, so going along, we first have to identify the control group. So the control group, like we said over here in the notes, is the normal, what would normally happen and what you're going to compare it to. So is Group A, your teacher giving you Monster while you're working, or Group B, the norm? Good. Group B is the one that we're going to compare to, okay? The independent variable, and if you want to look back up at the top again, the independent variable is what you are picking, okay, or what you are testing. And the dependent variable is what you are measuring. So I always like to pick the measuring one first because I can tell with the numbers which one has numbers. So you can say we're measuring the copied statements. So what is that defining? That's helping us define the productivity. So the dependent variable I like to do first. You don't necessarily have to, but I know that the productivity, or how many statements that they wrote, is going to be the dependent variable. And then the independent variable is what you are testing. What did I think would affect your productivity? And it says right here, she thinks the drinking Monster energy drink will increase productivity. So my independent variable is the Monster energy drink. Okay, so the control group is a class that didn't have anything to drink. We are testing if Monster can make you more productive. So independent and dependent. And now you've probably done some hypothesis stuff. Your hypothesis is usually at the beginning. Your hypothesis is usually at the beginning. It's what you predict or what you think. And it says that I think that drinking Monster energy drink will increase productivity. And so let's go down here to the bottom to see if we increase productivity. A that had the Monster got 1,587 statements copied. The regular people without the Monster got 2,113. Do you think that my hypothesis was correct? Was I right saying giving my students Monster? Good. I would reject my hypothesis here. Reject my hypothesis because less of the task was actually performed. It decreased the productivity. And usually in class, we can have a little bit of a conversation about this. Maybe if I gave it to the students in like a can, they had to like put down their pen to drink more or something like that. Maybe they're so skeeved out on caffeine that they are just like, woo, you know. So how could this experiment be approved? I've kind of gathered this list over the years. And so obviously you can always change the task. Maybe writing doesn't mean that you're super productive. A larger sample size is usually something you can always say. So doing it again, trying it again with more students. Maybe I gave them too much Monster. Maybe I didn't give them enough Monster. A Monster delivery system. Maybe if they have a hat, you know, where you can put drinks in and then they can just write and drink their Monster at the same time. I don't know. And then change the groups. Maybe switch to their side. Maybe there's just some slower writers in one side than the other. So kind of just always thinking about how you can make and redo an experiment and try it again to see if the results that you got are still the same. Okay, so what you'll see for the rest of this is that you have a couple other case studies in here if you would like to practice. The key is either in your parent packet or it is uploaded below this lecture. Okay. All right, the next thing we're going to do is we're going to go through a little bit of graphing. So after you took some time and you went through and finished that first worksheet, checked it with the key, we are now going to, I don't know if it's the next page or the next page. Go. You want to locate the worksheet that says presentation of experimental results. And so as you can see, it's the one that you guys can see on my screen. I don't know how much graphing we're going to be able to do in Schoology, but it doesn't hurt to draw a few graphs and go over it. So you want to find this worksheet. Most of the notes are already typed out for you. So if you have to draw a data table in this class, you're going to want to make sure that they're clear and organized. The heading should always have what it is and the unit of measurement for that. And then it will make actually doing your graph that much easier if you set up your data table correctly. And then the other thing that we want to make sure that you do is that you always have the independent variable on the, man, I cannot draw with this thing. I need to do something. The independent variable will be on the left side here. And remember, that is the variable that you are testing, and it goes on the X. And then your dependent variable will always end up coming to the right. And so there's actually going to be two rockets that we're measuring in the first data table. And if you remember, that's the one that you are measuring. So always the first column when you're worried about writing your data table correctly, and then it makes it easier to graph. The X is what you graph the first column, and you're on the Y, you graph subsequent columns. So again, the X, for if I was going to graph this data table, time would go on the X and mass would go on the Y. Okay, so speaking about graphs, what you would need to do is you need to do the following things. You always have to have a title. So we're going to work on that today. It's always very easy to just take some words out of the X and the Y. So for instance, if we were going to do this first one, you could say something like the distance that the rockets traveled per second. Or you could say, and for this one, the mass, and now you would kind of take a look at what happens, see how the mass is actually going down. So you would say mass lost per minute or something like that, okay? Or mass lost over time. Wonderful. Then you're going to label each axis, like we said. The independent variable, or the one that you're testing, goes on the X, and you know that the X is this way, the horizontal. And then the dependent variable, the one that you are measuring, the one that goes up and down, is going to be on the Y-axis. You need to put units on your X and Y axis, and it's always going to be very simple as long as your data table is appropriately done. So on your X, you're going to write time in seconds, and on the Y, you're going to write distance in meters. So as long as you have your data table correct, you want to make sure that it always fills up as much of the graphing paper as possible. Okay, you don't want your graph to be like, okay, there it is, and then have all this real estate over here. So making sure you scale it as much as you can. It doesn't always have to start at 0, as long as you keep the same consistent scale going across or up and down. Make data points clearly visible. Make sure you're drawing them nice and clear. And then if you have more than one set of data, which one of these at the top will, for instance, this first graph here, you're going to have a key. So you would have to have rocket number 1 and rocket number 2, because you're going to graph both of those. Okay. And then last thing to talk about, a direct or an indirect relationship. So maybe I would draw this here and then draw myself a little graph. In a direct relationship, the line goes up. Okay. As the independent variable gets bigger, also the dependent variable gets bigger. In an indirect, write a little line to yourself, the line actually goes down. Okay. And so as the independent variable gets bigger, the dependent variable gets smaller. So this is direct, and this is indirect. I'm going to have to figure out something to do. Maybe I'll have to sit at my smartboard or something for this. So hopefully you guys are feeling well with that. All right, so that's kind of the notes portion. So then let's go through here and talk about how to graph the first data table. And I feel bad because it's like flipping back and forth and back and forth. So maybe what you want to do once you're starting to graph this is pause the program with this on the front, so you see the data table, and then you guys are working on the back. So we're going to actually do the first data table, and I'll do it with you together. So the first thing we need to do is have a title. And so I would say distance traveled by the rockets over time, or distance traveled by the rockets in seconds. So distance traveled by 2 rockets. Okay, so you want a descriptive title at the top. Check, check. We did that. The next thing, we need to label each axis. Well, because our data table is correct, we're going to put on the x-axis, we're going to put time. So on the x-axis going up, oh, I'm sorry, that's not x. Work on that. On the x-axis is time. And on the y-axis is we're going to be plotting the distance that the rocket went. So I imagine that they had 2 rockets and they shot them off, and then they figured out how far they went per second. So we are going to label those. So on the y-axis, we're going to write distance, and the distance was measured in meters. You got to write, is the distance measured in miles, or not miles? We probably wouldn't use miles in this class. Is the distance measured in centimeters, meters, kilometers, things like that. Okay, perfect. So we did the first one, we did the second one. Now let's say the proper units next to the labels, we did that as well. The hardest part of drawing any graph is the scaling of each axis from about 2/3 to 3/4 of the graph paper. So what we want to do is we want to look at the smallest and the largest number that we have. So we start on the time on the X, on the horizontal one. We start at 0 and we end up at 36. Let's see how many dots we have. So I have 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we need to go between 0, 40, and we need to go 20. We have 20 increments in order to do that. So I want you to take a moment. I want you to think about, what do you think we can do for each one in order to get with 20? What should each one be increments wise in order to get from 0 to 40 with 20 lines? Good. Hopefully you think that each one will be 2. And the other thing you don't have to do is you don't have to write 2, 4, 6, 8, 10, 12, 14, 16, 18. You don't have to write them all. You can kind of chunk them together. So my suggestion is you go 2, 4, 6, 8, and then you draw a line. We're going to call this 10. And then we're going to say another 12, 14, 16, 18. And then we're going to say 20. And then 22, 24, 26, 28, 30. 32, 34, 36, 38, 40. And again, if I'm going too fast, just pause the program. You can catch up. Everybody loves graphing. All right, then we want to take a look at what goes on our Y, and we want to see, we go between 0, and this one goes to 98, and this one goes to 89. So we have to make sure we cover this whole rocket. And we can basically say it's going to go about 0 meters to 100 meters. So we're plotting this on the Y, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I think I'm supposed to have 20. I don't know what I counted wrong, but I believe there's 20. And so if I have to go 0 to 100 with 20, how many do you think each spot should be? Awesome. Hopefully you took a look at each spot, and each spot should be 5, or each line, excuse me. So we're going to go 0, 5, 10, 15, 20, 25, 30, 35, 40. Oh, that's right. I counted the 0, and I shouldn't have counted that. 45, 50, 55, 60, 65, 70, all the way up to 100. And again, if I went too fast, pause the program and catch on up. All right, so to finish graphing this first data table, the next thing, we scale the accesses, check, check. Data points clearly visible, key if needed. So we are gonna need a key for this one. And you see that you have 2 rockets. So my suggestion is that you have a key somewhere off to the side. And I would say rocket 1, rocket 2. You can either make like a solid line and a dashed line, or you can do 2 different colors if you have colors at your house. But either way, you need to have a key. Okay. Perfect. Good stuff. All right, so then the last thing we have to do here is we have to make sure that the data points are clearly visible and then figure out the relationship. So you take, and at time 0, both rockets are at 0. So we can just start, if you would like to, my first rocket is green. Let's do that. So we're starting here at 0. We'll put a dot. Then at 2 seconds, I'm doing my green, my first rocket 1, it's at 15 meters. So I'm going to go 2 seconds in, because this is 2, 4, 6. So we're going to go 15 meters. So I'm going to put a dot here, and I'm doing my green rocket. And then at 8 seconds, it's 32.5 meters. So I'm going to go 8, go up to 32.5. Put a little line there. And so I'm going to quick flipping back and forth for you. My suggestion on what I want you to do is I want for you then to say, all right, 1467. So go to 14, go go up to 67. Ooh, that would be over 65. I think I cannot do this on a computer screen. Hopefully you're having an easier time with paper. So what you want to do, and then you want to go back with a second color and you want to do rocket number 2. So at rocket number 2 was at 12.5. So let's change this color. So once you finish rocket number 1 at, I'm sorry, what? I can't flip back and forth. At 2 seconds, it was 12.5. Beautiful. So what I suggest you do is I suggest that you pause with this bad boy right here and then finish your graph, and I'll finish my graph, and then we can talk about the last thing is if it's a direct or an indirect relationship. So pause the program, finish graphing, and we'll come back. All right, so I did my graph here, and I had kind of just drawn it really fast. Again, not very well, but so we have, hopefully yours looks a little bit kind of like mine, and because they both go up at the same time, they are absolutely a direct relationship, okay? So hopefully you're feeling good with that. What you want to do to practice the rest of this worksheet is you are going to graph the second data table. Be very careful. Note that the mass goes down, so you're not going to have, you might not have a direct relationship. So take some time as your practice this week and graph that second data table. Then the other things that you will kind of have here is there is another practice reading graphs in your packet if you would like. It has just graph reading. The key to this will be also underneath this lecture. Okay. Then if you are in the honors class, all right. If you are in the honors class, you also have one extra worksheet where it's the scientific method in action. And these are some realistic case studies that we have. And you're going to be kind of pulling out, hopefully you know what a hypothesis is. I'm banking on the fact that you know those things. So you're going to go through and talk about a few extra things here on the real life case studies. So go through, answer those. The key is also online. If you have any questions, let me know. There will be a case study on the test. It will probably kind of be a little something like this where you have to read and tell me the hypothesis. You have to tell me the independent and dependent variable and all that kind of good stuff. So it wasn't the most interesting of lectures, and there was a lot of papers. There's actually 4. You can finish the first one reading the little mini case studies if you want more practice pulling out independent variables. You can do the practice reading graphs. You can finish drawing the other graph for the mass lost over time. And then you can do this scientific method in action here. So these are some actual case studies here. So I'll put something like this on the quiz or on your final test. And if you need more practice, the review sheet has some more example case studies that you would see kind of like the test. So the review sheet was written with the test in mind. So thank you. And we will let me know if you have any questions. Thank you.